Friends, during the previous few tutorials, we have studied about Z parameters. We saw how to formulate the Z parameter equations and how to transform the equations in the form of an equivalent circuit. We also defined the Z parameters and solved typical problems to emphasize the concept that we have learned. During this tutorial, we shall discuss Y parameters of the two-port network. We shall see how to obtain the Y parameter equations and how to transform the equations in the form of an equivalent circuit and how to define the Y parameters and also solve typical problems to emphasize the concept that we are going to learn during this tutorial. Let us go ahead. Friends, consider the standard form of a two-port network shown in figure. And in case of Y parameters, we know I1 and I2 are dependent variables and V1 and V2 are independent variables. And both I1 and I2 are the functions of both V1 and V2. Therefore, we can write I1 is equal to Y11 V1 plus Y12 V2, and this equation is called as the input port equation. Similarly, I2 is equal to Y21 V1 plus Y22 V2, and this equation is called as the output port equation. So, using these two equations, we can define Y11 is equal to I1 upon V1 when V2 is equal to 0. V2 is equal to 0 meaning the output port is short circuited. Therefore, this parameter is called as short circuit parameter. It is called as input parameter because it is the ratio of I1 and V1, which are both the terminal quantities at the input port. And it is called as admittance parameter because it is the ratio of current to voltage. Similarly, Y21 is equal to I2 upon V1 when V2 is equal to 0. So again, because V2 is equal to 0, this parameter also is called as short circuit parameter, and this parameter is called as transfer parameter because it is the ratio of current I2 at the output port to the voltage V1 at the input port. Therefore, it is called as transfer admittance, and of course it is called as admittance parameter because it is a ratio of current to voltage. Similarly, Y12 is equal to I1 upon V2 when V1 is equal to 0. V1 is equal to 0 meaning the input port is short circuited. Therefore, we also call this as a short circuit parameter. This also is called as transfer parameter because it is a ratio of current I1 at the input port to the voltage V2 at the output port. And this is called as admittance parameter because it is a ratio of I1 current to V2 the voltage. Similarly, Y22 is equal to I2 upon V2 when V1 is equal to 0. And this parameter also is called as short circuit parameter because V1 is equal to 0. It is called as output parameter because it is the ratio of the quantities I2 and V2 which are at their output port, and this is called as admittance parameter because the parameter Y22 is a ratio of current to voltage. So, if we write these parameters defined in the form of matrix, we get Y is equal to Y11, Y12, Y21 and Y22. And note that these parameters will reside in the black box and they are not accessible by the users, number one. And number two, all parameters are short circuit parameters. And number three, all parameters are admittance parameters. So, whether we call as Y parameters or short circuit parameter or admittance parameter, all the three are same. Friends, now we shall obtain the equivalent circuit of a network in terms of y parameters. We know I1 is equal to y11 V1 plus y12 V2. Now you note that I1 is a current term. Similarly, y11 V1 also is a current term because y11 is admittance multiplied by the voltage V1 will give us the current term. Similarly, y12 V2 also is a current term. Therefore, this input port equation is a KCL equation. This you have to note. Similarly, I2 is equal to y21 V1 plus y22 V2. I2 is a current term and y21 V1 also is a current term and y22 V2 also is a current term. Therefore, the output port equation 2 also is a KCL equation. So, if you know this, you can transfer these two equations in the form of a circuit as shown in figure. Now I will tell you how to correlate the equations and the circuit. If you consider the input port equation, by applying KCL we find that I1 is equal to y11 V1 plus y12 V2. So here you note that y12 V2 is a voltage controlled current source. Similarly, if we represent the output equation, we find I2 is equal to y21 V1. Again you note that y21 V1 is a voltage controlled current source plus y22 V2. So effectively now we have transferred these two equations in the form of an equivalent circuit. This is what you have to understand. Now we will see the features. What are the features of y parameters? As I explained earlier, all parameters are short circuit parameters and all y parameters are admittance parameters. Now you see that if the given network is symmetrical, you know how to find the symmetry property of the given network. So if the given network is symmetrical, then y11 will be equal to y22. Similarly, if the given network is reciprocal, then y12 is equal to y21. So these two conditions are very important to find out the property of the given network, which will help you to predetermine what the relation regarding y11 and y22, y12 and y21 I should get. Friends, now let us solve one typical problem to find the y parameters of the two-port network shown in figure. Of course, the options are given and we have to identify the correct option. Now if you examine the network, you find that the network is reciprocal because the network contains only passive elements. To find whether the network is symmetrical or not, we shall split this 10 ohm resistance into two resistances of 5 ohms connected in series, and you find that the left part of the circuit and the right part of the circuit about the symmetrical axis has a mirror symmetry, and hence the network is symmetrical. And you know, if the network is symmetrical, then y11 is equal to y22, and if the network is reciprocal, then y12 should be equal to y21. Now, you also observe that the input port V1 appears across this junction and the output port V2 appears across this junction. Now, by writing the Kirchhoff's nodal equation for the junction node V1, we get minus I1 plus V1 by 10 plus V1 minus V2 by 10 is equal to 0. By solving this simple equation, we get I1 is equal to 0.2 V1 minus 0.1 V2. By comparing this equation with the standard input equation in terms of y parameters, we get y11 is equal to 0.2 mho and y12 is equal to minus 0.1 mho. Similarly, by writing the Kirchhoff's nodal equation for node V2, we get V2 minus V1 divided by 10 plus V2 divided by 10 minus I2 is equal to 0. By solving this simple equation, we get I2 is equal to minus 0.1 V1 plus 0.2 V2. By comparing this equation with the standard output equation in terms of y parameters, we get y21 is equal to minus 0.1 mho and y22 is equal to 0.2 mho. By writing the parameters obtained in terms of matrix, we get y is equal to 0.2 minus 0.1 minus 0.1 and 0.2 mho. And if you observe the given options, we find that option A is the correct answer. Friends, we have solved the same problem by using different method and found that option A was the correct answer. Now we shall solve the same problem by enforcing the ternal quantity conditions and find the y parameters and see that whether our answer is correct or not. We know y11 is equal to I1 upon V1 when V2 is equal to 0 and y21 is equal to I2 upon V1 when V2 is equal to 0. So, to find y11 and y21, we have to enforce V2 is equal to 0. Now you see that once V2 is equal to 0, this 10 ohm resistance is short circuited, voltage across that is 0, current flowing through that is 0, and then so we can consider this to be open. In effect, you see that these two 10 ohm resistances are in parallel. Now, by writing the KCL to node V1, we get current through this 10 ohm is 0.5 I1 and current through this 10 ohm is 0.5 I1, same because both resistances are of 10 ohm each. Now, to find the ratio of I1 divided by V1, we know V1 is equal to 10 times 0.5 I1 and by solving we get y11 is equal to 0.2 mho. Now, to find the ratio of I2 by V1, we know I2 is equal to minus 0.5 I1 and by substituting for I2 and V1 is equal to 5 I1, we get y21 is equal to minus 0.1 mho. Similarly, we know y12 is equal to I1 upon V2 when V1 is equal to 0 and y22 is equal to I2 upon V2 when V1 is equal to 0. Meaning, to find y12 and y22, we have to enforce V1 is equal to 0. Now you see that once V1 is enforced 0, this resistance of 10 ohm is short circuited, voltage across that is 0, current flowing through that is 0, and then so we can consider that to be open. Now, to find the ratio of I2 by V2, you see that these two 10 ohm resistances are in parallel, and by writing the KCL for node V2, we get current flowing through this 10 ohm is 0.5 I2 and current flowing through this 10 ohm is 0.5 I2. Again same because the two resistances are of 10 ohm each. Now, to find the ratio of I2 by V2, we know that V2 is equal to 10 times 0.5 I2, and by solving we get Y22 is equal to 0.2 mho. Now, to find the ratio of I1 by V2, we know I1 is equal to minus of 0.5 I2, and by substituting the value of V2 is equal to 5 I2, we get Y12 is equal to minus 0.1 mho. So we see that the results that we got are same, and hence option A is the correct answer. Friends, we have solved this network by different methods and found that option A is the correct answer. Now, I am going to explain the most easiest method to solve this network because it is a pi network. Suppose if the given network is not a pi network, and if it is possible to transform the given network into pi network, then you can follow this procedure to find the y parameters very easily. Now, this network is a pi network. So what shall we do is, we shall transform all the resistances into admittances as shown in figure. This 10 ohm is equal to 0.1 mho, and let this be Ya. This 10 ohm is equal to 0.1 mho, and let this be Yb. And this 10 ohm is equal to 0.1 mho, and let this be Yc. Now, once we transform all the resistances into the admittances, then you can straight away write y parameters as we wrote z parameters in the T network. So, you can write y is equal to Ya plus Yb minus Ya minus Ya and Ya plus Yc. Now, we see that y11 is equal to Ya plus Yb, and by substituting the values we get y11 is equal to 0.2 mho. Similarly, y22 is equal to Ya plus Yc, and by substituting the values we get y22 is equal to 0.2 mho, and y12 is equal to y21 is equal to minus Ya. Note this, remember this. Hence, by substituting the value, we get y12 is equal to y21 is equal to minus 0.1 mho. So, you see that all the parameters we obtained are same as that of the option A, and hence option A is the correct answer. Friends, during this tutorial, we have learned how to formulate the y parameter equations and how to transform the y parameter equations into an equivalent circuit, and also we defined the different y parameters based on the terminal conditions that we have to apply. Also, we solved one problem by different methods so that you can choose the easiest that you feel. And during the next tutorial, we shall take up some complex problems and solve by adopting the easiest method that will enhance your basic circuit concept. Thank you for watching.